All right, welcome back. I'm back myself. Nice to see you for another week, where we're gonna be hacking on some code. Hopefully all the levels are good and all of that jazz. Just make sure I got everything pulled up here that I need to see, like chat and all that. We're good. Okay, cool. So we're working on a game called LambdaTrek, which is like a Trek-themed roguelike type game. If this is your first time tuning in, welcome. And this is kind of what the project looks like so far, where we're at. So it's built in Haskell, and we're using the stack build tool. We're gonna launch it like this, LambdaTrek, boom. Okay. We have a little panel here. We have our little view of the current sector we're in. The S is our ship. $signs space station. There's a little enemy ship. This little star over here, that is a star. Right? We have a command input area. This is like kind of very old school. You type in your commands as words and numbers and stuff. Put them in there. We have like a little dialogue area for like crew members and stuff to tell you what's going on as the game progresses. We've also been implementing and working on the galaxy map, or the quadrant map here. So the quadrant is made up of many sectors. The goal of the game is to like eliminate all these invading enemy ships before you run out of turns in the game. We just implemented long-range sensors in this map, so you'll be able to long-range sensors at different parts of the map. Our LRS-22. And that reveals, using your long-range sensors, what's in that quadrant. So in this quadrant there, well, we don't know if there's enemy ships in here. There's none. We got to change that. But we know there's a space station in here. So if we wanted to like now implement the warp command, which we'll get to, and warp over there, and there you can go. So we just have to finish up some of the long-range scan stuff that we need to do here. And yeah, now we're good to go. We can keep moving on. Okay, there. So let's go. We're going to make the empty scan result slightly different than that. Opening up our code. Boom, boom. Going over to source, LambdaTrek simulation, and over to quadrant, I believe. So in this module, we have all the data and code relating to quadrants and rendering them, i.e. the quadrant map there. And all the tiles and stuff like that. Quadrant tiles is what we're calling them. So we render a quadrant tile. If it has enemy ships, then all we can tell from the long-range scan is if there are ships there, not how many. In order to do that, you'll have to jump into the sector and get a better scan. So I think instead of a question mark, that's kind of confusing. We'll just use an underscore there. So maybe same with the player ship. Or we could just use an empty space. That might be fine too. Both empty spaces, that way they're the same. And then if it's unscanned, it'll show just the question marks. Or maybe it can just show one question mark, as in, you haven't scanned this yet. That might work better. Simple fix, small thing. Let's get our building going. So actually, I'm going to do that down here. We'll just build through the test runner. We use the fast compilation mode. That's just going to use bytecode. We don't need to like compile with optimizations while we're in development. It's just faster to do it this way, generally. That's why it's called the fast option, I guess. Stuff. Okay, so it's built. Let's run it. Go over their screen. There you go. Single check marks. So like when we're in this sector, it's kind of like automatically scanned. We don't have to use long-range scanners there. But now if we do this, we got there. Okay, cool. All right. Cool. What was the other thing? Maybe it should probably take a little bit. I don't know. I have to still balance out the different actions and how much energy they cost and all that stuff to make it interesting. If we do 2-2 like this, it's not even using energy. You probably should use some. So let's go make sure it uses some energy. I'll commit what we've got here, because that's pretty small and simple and self-contained. Boom, boom. So when applied, this change will just change how unscanned quadrant tiles are rendered. It's a single for unscanned. Otherwise, show what's there. Okay. Yeah, energy use. So that should be in the handling of the command. Top level simulation. Handle long range scan. There we go. Let's make it. Let's see. Let me use it somewhere else, don't I? Shift that energy. Just looking for where I've used, like, if I've implemented a deck helper function for decrementing the ship energy. If I just do it manually in all this code. Oof, I gotta redo that. This is an old school way of doing things. That's okay. We'll just do it. Okay, handle long range scan. We'll just do it here. Alright, so we update the game state quadrant that we scanned. And then we can zoom on the game state ship. And we can ship dot energy. And we have this handy dandy minus equals, and we'll decrement it by 10. Okay. So then that's for about to do that. We can go back to our map, long range scan, 2 here, and decrements by 10. That's good. Looking great. Love it. Boom. Ship it. When this applied, this change will decrement energy for long range scan. UI wise, do we care if the player uses the long range scan command from like this view versus this view? I mean, if you try to use it here, like, you're not going to see the effect. You're going to see the energy go down, but you have to go over the map view to see it. We probably should add some dialogue. Yeah, let's do that. Let's make it add dialogue too. Okay, we do have help for that. Just say dialogue. Helm? Helm should probably say it. Scanning quadrant. Let's render the coordinate directly. I guess using just a show. Yeah, maybe like that. T.pack. Show. Let's be cute. There we go. Chord. And might have to put that in parentheses and long-range scanners. And that might indicate that you have to switch to the long-range, the quadrant map. Helpfully enough. Hopefully. Oh, I don't have data.txt imported that way, do I? Oh, it's full text. Okay, full word text. Text. There we go. Let's bring it over like that. Sweet. And so when we do that, even if we do it from here, we kind of get it out of that. And then we can check our quadrant map to see. That feels pretty nice. Helm. Maybe we should have a science officer, you know? I think that's fine. Helm's cool. They can do that kind of stuff, right? In our ship, why not? This is the Lambda ship. Maybe we should make the ship not an S, but a Lambda. Now that I think about it, man, mind-blowing contributions to this game. Okay, so let's commit that as well. Boom. Add dialogue when scanning long range after long range scan. Add dialogue to long range scan. Something like that. Okay, so now that we have that, it subtracts energy. What else do we want the long range scan to do? Right, we didn't want to be able to scan just any sector in the quadrant with them. We wanted to be able to like implement a kind of a distance function to it so that you don't scan too far away. So you have to move from quadrant to quadrant in order to kind of like get there. Otherwise, you could just sit here, blow all of your energy that you have on scanning the whole map if you wanted to for some reason. Or it might be more like, okay, long-range scans can reach like the next sector over, or maybe 2 sectors over at most. That might make it a little more interesting. So then you have to move around a little bit to get the other ones farther away. Then you make more tactical decisions about your kind of local information that you have here. Because the other thing you could do if you don't want to use long-range scanning for whatever reason, as a player, right, you can just warp to whatever sector you want, as long as you have the energy to do it, and just arrive there. And when you arrive there, it should fill in the map as well. So it's another tactic you can use in your quest. Yeah, so maybe we should do it based on distance. Maybe we should just make it cost more energy the farther away you want to scan. Or a combination of like turns. We could also use that as a resource. Like maybe doing a long range scan far away takes a little longer to do, so it takes a few turns to get the results back. That could also be a thing. Let's go with the distance function for now, and then call that good enough. And if we want to tweak it later, we can tweak it later. Okay, so we're going to handle the long-range scan command. We're going to need to look at the current coordinate of the ship. And then we're going to have to figure out, based on the distance of the input coordinate, if that's too far away from the ship to scan. Okay. So we have two cases there where it's one too far away. Based on that. So let's get the ship coordinate, the current quadrant, which is the current quadrant coordinate in the game state, I believe. Yeah. That can be, what's it called? View game state board. My poorly named variable for the current position in the galaxy. And view is supposed to come from lens. That's my problem here. No, it shouldn't be that. Oh, did I actually rename it and made it better? So game state, okay, is in the state module. It is quadrant. No, it is sector. Even more poorly named. I'm awesome. Okay, view isn't the right thing. It is use. Yeah, okay. Use is the one. So that use is this little combinator from lens library that like reach into our game state structure using this lens and pull out the right field. So we don't have to use like methods from the state. We just do it directly. Anyway, got the coordinate. Now we have two conditions we can test for. We could probably just use it if distance from forward to current chord is less than, say, 1, less than or equal to 1, less than 2. All right. Even less than equal to 1. Let's the other way around. Then this, else that. If it is this, then we're going to do all this stuff. I think now it needs to be inputted like this. This needs to be inputted like that. Blah blah blah. Therefore form. Else, all right. We're not going to perform anything. We might still say dialogue from Helm. What would they say? Captain. Text dot go chord. Is beyond our sensor, long-range sensor range. And then we do pure denied. So we don't have distance. Let's see, in range. That's the basic function we want. That one is a little bit specific to things that has position. We just have tuples. We could implement that class for tuples. specifically tuples of int int. This is almost trivial. And then we can use this handy dandy function in range. So we say in range chord, current chord, and just one. Super. Let's see. Okay, that's... Haskell's going to complain about that not being a properly formed instance. It's kind of annoying-ish, but I think this will be okay to use and solve our solution. And we should just follow GHC's advice. Or not advice, suggestion. Okay. Not the prettiest thing to do, but it's fine. It's a small program, it's not a huge deal. Okay, so now we should be able to do like long range scan 4. Oh, sorry, 3. Then we got beyond our long range sensor range. Super. But if we do 2 also, but if we do long range scan 1 that should be okay. No? 1 should be this one. I must be mistaking. What did I say? In range. The in range function. If I say 0, 0, I bet it'll be okay with that. Yeah. Okay. So we just have to change in range to 2. So this argument here, I think, in range is not inclusive. A coordinate is within I need to have to do like range distance. Oh, I think literals you have to use at. And range is not inclusive. If I'm right about this, we change this to 2 and we should get the behavior we want. Alright, so long range scan 3, and that's this. And so 0 index, so this would be 0, 1, 2, 3, 0, 1, 2, 3, right? Should be this bottom corner here. Beyond. Okay, now 1, 1 should be 0, 1, 0, 1. So it should be this one here, which what we want is that to be a valid one. Right? So this one should work. Okay, and it scanned it. Scanned the right one, yeah. Alright, 0, 1 should work. Yeah. 1, 0 should work. Yep. Well, we did 2, 2, that should be outside. Yeah, okay. Yeah, so that's right. So range in that in-range function, that variable is not inclusive. Good to know. Documented that there. Good, good. So when this change, long range scan, will modify long range scan, limit the range of the scan to adjacent sectors. Boom. All right. What do you think, chat? Should we implement warp drive now and be able to warp to different sectors? I think it's time. The next logical step. Okay, so let's do it. Let's go to command. Well, we actually need to set the warp factor first. So let's add that to our ship. Although, hopefully warp factor isn't trademarked. I should choose another name for my inspired game. Warp factor 5. Okay, consultancy. Okay, no. Phaser, I think, is. Okay, so that should be fine, hopefully. I'm not a lawyer, but, you know, this is a small pre-game. I don't think anybody's going to be terribly upset. We got a few things off here. And I'm open to changing things, if you ask. So let's do it. Ship warp factor. We'll just represent it as an integer, even though, well, let's use a type for it. Because there's only certain logical values for it that we want to restrict it to, and constraining the range of valid integers, it makes for a more annoying code than just if you can get away with a small amount. An enum would be even better than warp factor. So that's what we're going to do. Warp factor. We'll do 2. 4. 5. That's good enough. Like, you don't have to go all the way up to 8 or 10 or whatever. We'll make this a bounded and enum. So it'll be like a direct correlation to the integers, like to and from different constructors here. That's all through the enum class. So that may come in handy. We'll see. We'll need ord as well, I guess, so that we can have the show instance for our ship, which is handy for debugging and such. And of course, we changed how ships are represented, so we have all this game state code change probably there. I bet in the test modules as well. So initial game state, we initialize the ship. The warp factor is the last one, so we use warp factor 1 as the initial. There's the test modules. I think they're all 0.755, so hopefully this will be a nice quick string replace. .75, 5, and we're going to replace that now 0.75, 5 with warp factor 1. Bam. Okay. We're building again. We're green again. Add warp factor to the ship. Okay, and now we should be able to implement the commands to change that, but we could first render it. And we'll use the enum class probably in the rendering, so we don't have to write an explicit rendering function here. Which is just I'm just gonna represent it as an integer in the UI. Anyway, in the info panel there. So we'll do that. Okay, so we'll hop over to our UI code. Now for our UI, if this is your first time tuning in again, or your first time tuning in again, I don't know why it would be again. Anyways, the UI code is built on Brick. Brick is a handy, dandy, super duper, wonderful little library for Haskell. If you haven't tried it out, it's what powers the whole thing, UI-wise, and it's very cool. If you ever need to make text UIs to like mock up something quick or make a little quick tool for yourself, highly recommend checking it out. Very useful. Okay, so our info panel widget is defined over here. Let's go ahead and add a row for warp factor. I'm going to add it above remaining turns. Actually, I put it after energy. Seems good. Yeah, anyways, okay, so we'll put a string there, and then we need no string here. We'll do the show of the, after we do from enum to enum on the game state ship. Yep. Dot warp factor. From enum. There we go. From enums comes from the enum type class that turns it into an integer that represents the constructor numerically. Super handy. So now that should show up there. Warp factor 0, that's where we start off. Ooh. They're 1 based or 0 based indices. And we represent warp factors as 1, 2, 3, 4, 5. So we'll just cheat a little bit. It's ugly code, but you can write ugly code in Haskell. It's fine. It's fine. There you go. Warp factor 1. That might be a little confusing to someone if they didn't know. So, do I feel gross about using this? Kind of. At least we could put it closer to the definition. We could do like we call it to numeral. Or we could call it warp factor numeral. I might make it a little bit more clear, maybe. Call out here. Warp factor. Maybe warp factor to int. And that will be, yeah, the +1 after from enum. Oh, what's the warning we had there, actually? Check that out. Simulation 64. Ooh, handling engine move. We probably should do that. We should also fix this code. Yeah. I like it when code compiles without warnings. That's so nice. It's a nice thing. Okay. That looks good. Alright, so there we got our warp factor there. That's great. Cool. Okay, warp factor, yeah, warp factor numero, boom. So this, add warp factor to info panel UI. Okay, and now we need commands to change the warp factor. Warp factor, give the warp factor. Then, turn cost. One. And what's this warning? Yep, that's good. We want to fix that. Here in handle command. We'll just make sure it doesn't do anything at the moment. Just so we can get back to compiling again. Super. The warp factor command. Okay, good, good, good. Let's add the parser for that command. Parse warp factor. And this will be the read key for warp factor. Which we're going to need. So we're going to go do here. We get a number, an integer. All right, so let's get a digit. We'll call it X, and we're going to digit. And then we have to check if that digit can be converted to our enum. So they're going to give the digit in terms of like 1, 2, 3, 4, so on and so forth. So we need to decrement that. We get nothing, then we have problem. Otherwise, we do have a warp factor. And so we should actually turn this into maybe an either. I think either command parse error or warp factor. And oh, what is 2enum? The type is int 2a. Right. Oh, I think I know what's happening here. So I think way 2enum will work is if it gets a value out of bounds, it'll use the minimum or the maximum value of the enumeration, I think. That makes sense. I don't know if we should use that or if there's a way to make it return maybe. I'm just gonna look that up quickly. Enum from 2, from then 2. Error, maybe? Maybe from enum error? Let's just return, no matter what you parse in there, warp factor will just that compiles. And then let's just pull up a REPL here. That's fine. Okay. Let's import our module LambdaTrek. Simulation ship. And we want to, from enum, to enum error. String A, shortable A, and A is type. Okay, so A is going to be our warp factor. Ooh. What's the other part? A. Give it 3. Oh, we need to import that as well. Okay. Import data.enum, ghc.enum. Now we're going to do warp factor. I did need type applications. Okay, so that's going to set the A to warp factor. So I think that means we have to do this should be a warp factor now. That should be an int. Okay, then that means int, and we want a warp factor. I'm not understanding what's happening here with these functions at all, am I? So I guess, well, if we match these to the 2enum and from enum, right? Well, that one's an int. Okay, so we want to try two enum error. So we're going to go from int to our constructor. So first argument is string. Whoop. Our integer. I'm not sure what this tuple is all about, though. I have no idea. So what the heck is that? Okay, I'm not liking this one bit. I think I'm gonna get rid of the enum stuff. So instead, when we write this parser, we're going to get the digit, and then we're just gonna case match on it. If it's 1, and we know that's warp factor 1. And let's just make this factor equal listen to it there. Warp factor 1. We could probably actually move this to a function in our module there, which I'll do in a second here. Let's just get this working. Or this is what we should have done in the beginning, I think. Warp factor 5. I don't have to repeat this all over the place, but I'm going to. Maybe we should just write this out here. Yeah? Yeah, because if the digit, we can't pattern match out any of these other digits. They're not valid warp factors. We can make a left here with our command parser, invalid warp factor value, invalid warp factor. And then we can cure factor. We just implement that error. Yeah. Invalid warp factor int. And then I have to render it out. And we will do our good old text dot back. Show val, and we'll wrap that up as valid warp factor. That. Don't have text imported that way. Okay, import qualified data.text. That's text. Boom. We'll sip. And we're compiling again. That's good. Okay. So, well, we're not quite done yet. What's the problem with this? Deduplication. Don't worry about that. Deduplication just yet. Wait, what? Found skip spaces amount, skip spaces patch combined with 137. No, it's not the same thing, but thanks. Okay, so that's parsing the warp factor value. Now we can parse the warp factor command. And we want to return command. And here we're going to match the string as we do. Factor and we'll skip spaces. And we'll get the factor using our new parse warp factor parser. And then we can return the warp factor command. And that should be either. Like that. What's the problem with this? Couldn't expect type warp factor. Type factor isn't the right type. And what we got here is an either command parser. I was expecting that to be the result. What is... Right, okay. Why does this make... This does make some kind of sense. Yes, okay, so yeah. It's fine. So parse, we're just getting back either command parser, warp factor, of course, and we need to dispatch at either. For some reason I had in my mind that this would dispatch that, but it's not part of read P. We're in read P here at this level, so yeah. I kind of want to run that parser, and if it returns a left, just return the left. Or give me the result. Like, I want another function here. Like a combinator that does that. But we can just handle this the ugly way. This is fine. If it's a left kind of thing, which is just pure factor. Sometimes if you don't know how to write out the combinator, it becomes apparent when you write out the code longhand and you just go to a refactor step later. And, like, you don't need to write it off the bat right away, either, like I was about to. Because if you only use it once, then it's not very useful. But then the pattern match is just fine. So this is factor result. Otherwise, we have the warp factor. And then we can do factor here. Factor results. Okay, yeah, the parse warp vector here, the type isn't command, so that's not going to work exactly. So we'll just have to rewrap it. Cool. This is still annoying. I think there's a way to ignore hlint on a particular line. I always refer to this blog post quite a lot for how to do it, because I always forget, because I don't do it very often. So I like to use this one, I think will work. There, copy. Hlint, like that, yeah. Ignore. We can give the string of like the error message in particular that we want it to ignore. I'm just gonna put the whole thing. Okay, that compiles. No warnings. Good, good, good. Nice and clean. And then we just add the command, the parse warp factor command here. Cool. And I think if we run the game now, we should be able to see that working. Boom, boom. Factor 2. Factor 3. Oh, but we're not handling it yet, so. But it's working. We're not getting errors. So if we try to do factor 0, invalid warp factor. So that, like, we know it's there. That's nice. I like it. Okay, okay. So we just need to add the handler for it. Warp factor command parser. And then let's add the handler. Handle command. Handle warp factor. Put that down here somewhere. But I have to long range scan, so good, yeah. Handle warp factor. That's gonna be a state, game state, unit. No, not unit. Result, command result. Okay, handle warp factor. Let's go to warp factor. Do that. So we could lambda case on that. Maybe 1 factor 1 like this. Could do it that way, break it out. Although I don't think these are going to be very interesting to do it that way, you know. Let's just stick at the factor in. Because basically all we're going to do is zoom in on the ship in the game state. And we're just going to set it. Warp factor. And that's going to be equal to factor. You need to import that. Yep, shield state and warp factor. Then we'll say dialogue, helm, hi captain, warp factor, and then we can use our function again there, I think, to show that. Do we have that text back? Warp factor numeral. That's on your ship. Yeah, what's the problem here? Bam, bam, bam. Right, we have to return that we did this. So our command results, process performed. Period on the end. Hopefully that's consistent with how I've been doing dialogue. If I don't need to add period, I'll take it out. Okay, here we are. Factor 3. I warp factor 3. Move to the 3. Move 2. Phasers 30. Is it phasers 30? Well, that's the command, right? Yeah. Doc. Yeah, I seem to add punctuation on the end of the sentence there. Consistently for that, so that's good. Yeah, even there too. Okay, good, good. Excellent. Sweet. Okay, so let's add that as well. Boom. Added. Commit. Handle. Blah, blah, blah. Warp factor command. Okay, now we can set the warp factor. And now we can actually do warping. Because we need the warp factor value to determine how much energy it's going to use and how many turns we use to get there in our equation. So there. With that, let's go add warp. Ooh. Ooh. We, instead of calling it warped, I think originally I had implemented that and called it jump move instead of engine move. And we had this quadrant chord whole thing hacked out. Which is funny. Totally forgot about that. Hilarious. Okay, so simulation. Where did we define quadrant chord? I'm gonna just do a little fine graph. Units. Okay. So smart. Was I? I implemented quadrant coordinates and we didn't even use it. Yeah. Whatever. We didn't use it. It's fine. Let's get rid of it. Get rid of that. It's not going to compile anymore. Until we get rid of it and we fix that. No, not that. This. I'll get rid of jump. We're just going to call it warp. Warp, and then this is just going to take our coordinates. Int. Okay, and then we have to add a warp here. This is going to be... We're going to have to fix up turn cost. This is no longer useful to have just the parameter. We're going to need the game state. Because in order to actually calculate how many... We want to dynamically calculate how many turns warp's going to take. For now, I'm just going to leave it as 1. To do... Dynamically calculate turn cost based on a current warp factor. Okay, so we're gonna have to do that at some point. We're gonna leave that for now. And we have still builders, of course. Parse. We added a parser for jump as well. Oh man. Talk about jumping the shark. It happens sometimes. So do bad jokes. But I earned my bad joke license when I started having kids. You can have yours too, just because they're free. There's no membership requirements or anything. Funds are for everyone. Okay, and then in simulation, when we handle it, then we have to handle warp. And we're going to just do pure deny because we're not going to do anything yet, not implemented. Okay, we're back to green yet? quite. Yeah, we still have more stuff to remove out of parser. Oh, the phaser manual command too. Yeah, didn't implement that. Yeah, and then press jump move. There we go. Back to green. Okay. Alright, so in this case, what did we do? We just... added warp handling to a few places. Okay, we're kind of tying up two changes into one here. That's okay. I think it still makes sense. Stage it all together and replace jump move with warp. Okay, there we go. Boom, boom. Let us add the warp command parser. Read P. Either command parse error command view, we match the string, then we get a coordinate. I think we have a parser for that. Yeah, parse coordinates. I need, or just coordinate. Yeah. It's not going to do a space first, so we'll do that. Warp X and warp Y. Okay, and then we're going to validate that those are valid warp coordinates. Back. Just call it warp chord. Warp chord of warp X, warp Y, such that warp... Actually, no, hang on a second. I think more than coordinate, I think we also have the warp... and even LRS uses the same sort of thing, with the same validation. So we're going to be kind of repeating code a little bit here. A little bit. I'm just going to copy paste it. And I'll replace that with warp chord. Yeah. We still have to fill in this with our thing. In the error case, and what do we put here? That's the thing. That's the thing we need to solve here. So, we just need to put the warp coordinate command, the warp command. And then we need to implement invalid warp chord. Text, I should say. There's just going to be another message here. Okay. So that should be implemented now. Oh, we haven't hooked it up to command parser yet. So, yep. Make sure we do that. Parse warp. Now it should be hooked up and ready to go and used in the game. Even though it doesn't do anything yet. Well, okay. What do we do? Let's warp. Oh, we forgot to skip space. Skip spaces. Probably just add a skip spaces here as well. Okay. Okay, so that's valid, but if we do for that would be right. Okay. That's cool. Let's commit that. The warp and parser. And then we actually have to implement the handler. Oh no, we have two things. We have to implement the handler, but we also have to implement the turn move calculation stuff. We have to fix that up. Okay. So let's go to simulation, command. Turn cost. Turn cost, I think, is used in simulation. Figure out how much the command costs. It happens in a state. So we could refactor this to be a state function over game state. And handle this. And we'll probably have to move it into simulation just to avoid import cycle. So that's what I'm going to do. I'm going to move that here. Move it here. Okay, and then we're going to change this to be a state. Game state, returning an int. And then we'll call it like this. Command cost, turn cost. Still need to give the command. And then we do command cost. This. These all become sorry, let me do what I was actually meant to do, which is line them all up. And line that up. This becomes just pure. Okay, so it should do exactly as before. Okay. Test still pass. Looks like yeah, we moved, subtracted the move cost, engine move costs 2. Good stuff. Okay, so now we can interrogate the game state to make our calculation here for warping. Okay, so let's do that. So here we want to look at the ship. So we're gonna use game state ship and the current coordinate. Sector coord. I think it's not too badly named, but still kind of somewhat confusing, I think. Sector. Okay, and then we have the warp X, warp Y coordinates. Line those back up, there we go. And now, yeah, okay, there we go. We have our ship, warp Y, warp X, our sector coordinate. Okay, so now we need to figure out how far away the sector we want to warp to is. And so if we have a distance function, we sort of do, we haven't given it a name. Let's call it distance. Try to make it a little bit reusable with like our in-range style stuff. It turns an inch. And how do we rate this? Almost exactly like that. Right. And the only difference is that we're going to return this expression here. Okay, and then that means we can change the definition of in-range to use that. So we can get rid of this. This. I can get rid of this lip binding altogether. And our range just becomes distance AB less than or equal to range. Okay, what's the problem here? Well, we couldn't match it with type int. Because abs is going to turn on A. Ouch! Of course, A and B aren't in scope. There. Okay, we're getting close to the end of the stream, so I'm starting to get a bit of stream brain. Let's call them X. Y. Okay, so that should be good now. Bum, bum. All right. So the distance between sector Colord and warp X, warp Y. Okay, so now we have the distance between where we currently are, where Captain's ordering us to go, and now we can use this to determine how many turns this should cost us. So we should have like a base rate and multiply it by the warp factor to make it simple. So we'll do it like, it'll be a good growth curve, like 0.75 times the warp factor. Round it up. Ceiling. Excuse me. Let me get a drink of water here. So we get the pure, we get the ceiling. Pure after ceiling, after... this expression here should be 0.75 times distance. Why did we need the ship? To get the current warp factor. Right. So that's one part of the equation. Or from... integral. Oh, what am I doing? Ceiling. Ah. Okay, this is one part of our formula there, right? Is the distance, how many we want to go. That should be like a constant amount. And the warp factor. No, that should be int. Okay. Something to grow. Mm-hmm. Yeah, okay. Okay, so we take the ceiling of 0.75 times dist. So if dist is like 4, we'll get basically 75% of that amount. And then we want to multiply that by our warp factor. So I think 0.75 should actually be higher. Maybe 2. Because the coordinates aren't very far. So two times the number of distance. And maybe multiplied by the warp factor of the ship. Something after ship dot warp factor numeral. Warp factor. Something like that, right? And this will also be from integral. We don't really need that because we're not multiplying by any kind of fraction amount here. And brackets. Okay, and there's that from Google as well. Okay, so hopefully that feels about right. Let's try it out. Boom. Okay. Let's warp to 2-2. Right, we didn't implement the handler for it. But the turn cost is there. So we can see if this works if we just change this from pure denied to pure perform, even though it doesn't do anything. Warp 2-2. So it calculated it would take 8 turns to warp to this new place. We haven't fully implemented the warp, but we've done the turns. So we go warp, let's say 3-3. That'll be a full 12 turns. And if we just warp 2-2 back to the middle, it's just 8. We might want to scale that and change it, but that part's working. That's cool. So now we can remove that to do. And move this back to red. So if you're just your first time tuning in, you haven't really been following along, all the perform denied stuff does is just our command result, which just tells the main game loop if it was performed, then actually do the command cost and update the turn. Set the return cost for like actually performing the command. Otherwise, if it wasn't performed, don't do anything. Just clear out the state to handle the next. Update the enemies and handle the next input from the user. And await it. So yeah, I'm just gonna get that there. Any hoozle. Okay, so let's go implementing handle warp. We've got a little bit of time. Should be good. Let's just do X and Y. There. Alright, so let's jump over to handle warp factor. We'll put underneath here. Handle warp. We're gonna get int, and there's gonna be a state, aim state, and results. Okay. So all we really need to do to actually handle the warp is just change the current sector coordinate. And then... oh, then we have to update the ship's position within the sector. That will be a little bit trickier. Because we don't want them to jump into something they can't collide with. And... yeah. We'll have to figure out an algorithm for picking the safe space for the ship to jump into when they arrive. Or we can update the warp command to take that as input, maybe. But let's figure about that later. Let's just do the warp as if it would succeed no matter what. So then all we have to do is set the game state sector. Because we know warp X and warp Y are valid. Because the parser wouldn't parse an invalid coordinate. We could just set that directly. Say dialogue from helm. Hi, Captain. Setting course for sector. Blah, blah, blah. Desktop pack. After show on warp X, warp Y. At warp factor. Desktop pack after show. And we're going to need the current warp factor of this ship. And we'll just call it warp factor. And we can grab that by use our yeah, use. And we'll use game state ship dot warp factor. Yeah, what do I got here? And then we have to return the command result. Performed. My use of lenses here. What am I doing? Blah, blah, blah. Okay, don't, it doesn't like that. Let's just make it the ship. Let's not get too fancy with our composition here. We can always do ship warp factor here. Cool, let's see it in action. Let's warp to 2-2. There we go. We're now in sector 2-2. Let's see, we didn't... Interesting. Okay, hang on a second. How come remaining turns didn't decrement energy? So we're not quite there yet. Almost. What do we miss here? Right, it was performed. Alright, so we should have gotten this. Yeah. Here's the bug. Can you spot it? This is hopefully a pretty simple fix. So we determined the command cost after updating the state. In this code here, when we're determining the command cost, we're assuming the state before actually performing the action. All right. So in order to determine the actual command cost here after the command has been performed, we would have to know what the state was before and what it is now. But for the most part, we can just move this calculation of the command cost before we handle the command. And then if it was performed, then we can decrement that command cost. I think that'll fix that. And then we just have to update the energy formula. All right, so let's check that out. All right, warp 2-2. There we go. So the energy is calculated properly. And then we change sector. Like there's no enemy ships here, so. Okay. Okay. Now, let's do the energy calculation, the energy use. So, how much energy should it cost? An amount depending on the current warp factor. The higher the warp factor, the more it should cost, and how many spaces you're moving. Okay, so in order to calculate that, let's see, we've got let's get the game state sector as it exists before we mutate it. Then we set it to the new one. But before then, we get the distance. Yeah, distance will be dist. That distance function we wrote between game state sector and warp X, warp Y. Call it current sector. Not to overlap. That's just some inference funniness, because we're using overlapping names there. Okay, dist. Boom. Okay, so that's the distance we're going to travel. And we said we want the cost per sector moved to be the distance times the current warp factor. Use game state ship. Oh, we already have that. Let's just move it up. And then we can get the ship warp factor. Which I'm going to pull out of the ship. Ship warp factor like this. Okay, it's good. Love it. Good. Yeah. We'll do that. We're going to multiply by the warp factor. We're also going to replace that down here by the warp factor. Beautiful. Love it. What's the problem here? Okay, warp factor isn't a numerals, right? So that's ship dot warp factor numeral of the warp factor. Okay, so that's the cost per sector to move. And then, let's see, we want the actual energy consumed amount to be that times cost per sector times the number of sectors we're moving, which is gonna be like basically dist. So like dist squared. If we're to like factor this all down. Let's just, we'll do that in a second. Game state sector, we're gonna update the game, the ship's energy. So we're gonna zoom in on the game state ship. And we're going to set the ship energy to be minus equal the energy consumed. Yeah, cool. Let's check it out. Alright, let's warp out of here. Right on. Okay. The farther we warp, the more energy it uses. We can tweak that as we like. Let's just factor this down a little bit. So we're using dist here and dist here. I think we can do this all in one line. It's like dist times dist, or dist squared. Yeah, that should be it. Okay. And we warp like 3-3. Takes quite a lot of energy to get there. At warp factor 1. Right? And if we change our warp factor to 4, it should be even like crazier. Not crazier, but like even more energy use. So we go to warp 3-3 now. We even go right to negative energy and trigger the game over state there. We should probably have some checking for that. To do, check that, but we're out of time, but we're gonna add that as a do item. Check that we actually have enough energy before engaging. All right, because we had a really high warp factor. We would get there faster in fewer turns. So we should probably add that to our dynamic check there as well. A note to do. Calculate fewer, or should take less turns at higher warp factors. I think this formula is making it take, yeah, this is not a good formula. It's taking more turns the higher your warp factor is, or it doesn't even care about the warp factor. No, it does care about the warp factor, but it's taking more based on warp factor. It should take less based on warp factor. So that's not right, but we just need to tweak the formula there. That's it. Okay, so next week, that's what we'll work on. We'll just tweak that around so that warp fully works. We have enough energy before engaging, but basically the gist is that if we give like a factor, maybe let's try 2, and we try to warp through 2, it should take quite a bit more energy than just 1. So that dropped us all the way to 68, right? And we set a factor, and if we just warp 2 without setting up warp factor, 2 should just be like quite a bit less, 84, right? So the higher your warp factor, the more energy you will consume to get there, but you'll get there faster, right? In fewer turns is the gist. So we need to tweak the remaining turns formula for that to take that into account. The energy, I think, is looking pretty good. We just have to do that validation that we have enough energy to jump there. Otherwise, Helm should say, like, we don't have enough energy to do that. Something like that. Cool. So let's look at our commit histories, see if we can push up our code. So this change, we're adding warp handling, some rudimentary warp handling. So let's stage that, let's commit it, add basic warp command handling. We don't calculate the turn based warp factor properly yet. That energy is good. Except we need a check or sidekick case. Check for enough energy. Jump the warp before living. There you go. Yeah, okay, that's good. Okay, let's see. I think we can rebase, just kind of compress it down a little bit. Let's go here. Okay, reword that one, switch that one into it. That one. And reword this one, squash that. And then reword this one and switch those two. Okay, so this is going to be implement. This will add long range scan. Update long range scan. Scans are limited in range. They use energy and turns. So warp factor to the ship. We're going to add warp factor command. And we'll just compress all that. Added. And rid of that, move that up there, make a nice little list. Probably nicer command, a nicer commit message I've ever written for myself and viewers. So we had the warp factor command, added warp factor and ship warp factor. I'll just add warp factor. Add warp factor. Ship. Warp factor command, parser. There we go. Add warp command. Mad with that. Squish all these up. And that. And that.
So don't call me a moron, I'm super astute. There is no conundrum that my core cannot confuse. No, don't call me a moron, you frosted balloon.
We're going to change this to add basic workman handling. Actually, we just added basic warp command handling. That's good. Yeah. And warp up. Okay, that looks a little nicer. More succinct. Let's push those up. Okay, so thanks for watching this week. If this is your first time tuning in and you haven't seen the stream before, I do these once a week, usually on Tuesday evenings, about 10 after 8 in the Eastern Standard Time Zone. So if you want to tune in next week, you can just try and remember that, or you can subscribe and follow on here, on the Twitches. And if you're on the YouTubes, you follow my channel there. You can like and subscribe maybe, and then you'll get notifications when I post new videos. Or if you're here on the Twitches, and you'll get notifications when I come online and do stuff. Because sometimes I do things off schedule once in a while. So yeah, it's a pretty good idea to follow. Maybe it also gives the channel a boost. So, but you'll know that probably. What else? Yeah, the code. It lives up on GitHub. I'm Agent Ultra. It's been a pleasure. That's my socials on the Mastodons. GitHub.com/AgentUltra/LambdaTrek. This is the project we are working on. This is where the code is. It's up on GitHub. So there you go. Added the warp command. Boom. So now we can warp to different sectors. Yeah, follow me on Mastodon. I'm on the types.pl server. Follow me there. Or you can go to the link above as well. We have a Discord server there with a channel for this channel where you can chat about your projects, any questions you want to ask off stream you didn't want to ask on the stream, or just want to chat about what you're working on, whatever. Bring the heat. It's all good. And yeah, generally pretty nice people there. There's a lot of other streamers and things doing streams in other programming languages as well that you might find interesting. So it's a good community, well worth checking out. And that has been that. I think it's time to say goodbye. So may all your monads be free. May your types always check. And we'll see you next week. Peace out.